complex numbers, right? This is a complex number, a plus bi. You did this last year in algebra. In a number like this, a is the real part, right? B goes with the imaginary part. The real part has to always come first. This is called a complex number in rectangular form. You don't have to remember that. I'm just telling you for your use. Okay, this is a complex number. And polar form, which is what we've been doing. Do you remember the term polar form? Polar form means we're putting cosine and sine and all that in there. All right. Polar form looks like this. I'm going to put a z. Z just means it's a complex number. Z is equal to r cosine theta plus I sine theta. That is a complex number in polar form. We have both forms. Now, what we're going to do today is we're going to go from rectangular to polar and polar to rectangular.
So the top one is rectangular form.
This one is rectangular. This one is polar. All right? Rectangular has an A and a B. Polar has an R and a theta. R is my radius, remember? And what is theta? Angle. Okay? Now, things you might need to remember that you don't remember. I don't know if you remember or not. Do you remember? Now, this is a plus bi. It would be the same thing as x plus yi. They've replaced x and y with a and b. Just because because for a plus bi, you're not on a coordinate plane, you're just numbers. So they're not using x and y, they're using a and b. Do you remember that a is r cosine theta?
No.
B is r sine theta? That's from before Christmas. Okay, would you remember it if I said x is r cosine theta?
No.
Because would you remember when I said cosine theta is x over r?
Yes.
Working with the same thing. We're just putting it in a different form. So would you remember y is r sine theta? Or sine theta is y over r?
Yeah.
Okay, so it's kind of all starting to come back a little bit, right? Another thing, I don't know if you realize or not, but r is equal to the square root of a squared plus b squared. Does that make sense to you, Pythagorean theorem? Now, one last thing to see if you remember. Do you remember tangent of theta is b over a? Is it tangent theta y over x? Just switch letters. Okay, this is kind of all the information you have to remember. You ready? You ready to do it? Sure. All right. If I give you the number z equals 3 plus 4i, what is A?
3.
What is B?
4i.
No, B is 4.
Oh, yes.
Remember, it's BI? So you have to realize A and B are just the number. Okay? Is this rectangular or polar? Rectangular. Agreed? I want to change it to polar. So what I need is R and theta. Right? How do I find R? Which is, so what is R? Five. Right? What is, you're not going to like theta on this one at all. What is theta? Is the tangent of theta equal to 4 over 3? So is the arctangent, is theta equal to the arctangent of 4 over 3? Give you a minute to process that. Is it? So this is rectangular. Polar is R cosine of the arctangent of 4 over 3 plus I sine of the arctangent of 4 over 3. Because I cannot get an exact angle. So that is the answer. What, Chandler? Now, I have to admit, I started with a hard one. Probably shouldn't have, but I did. So it's okay. Let's do an easier one. You okay if we do an easier one? Z equals 1 minus I. What is A? What is B? Negative 1. Right? Okay. What is R? No.
No, it's not. Square root of 2. Wait, square root of 2. Yeah.
So 1 times 1
Is 1.
Oh, it's 2.
So R is radical 2. So radical 2. Now, 1, negative 1. Remember I said A and B replace X and Y, correct? So if I did that, X is positive, Y is negative. What quadrant am I in? 4? 4. So my angle's here, right? Isn't this one this negative 1?
It's the other one that right two.
So what is this angle right here? No, the angle, not the number.
Pi over 4.
Thank you.
What am I saying wrong here? So the angle is pi over 4.
What is this?
Oh, that's pi over 4.
So is that my angle? So cosine 7 pi over 4 plus I sine of 7 pi over 4. Right?
Was that the answer?
That's the answer.
So we don't have to solve for it.
No. You're just converting it. Can we do another one? Negative 4 radical 3 plus 4i.
I take back what I said.
What?
This is not that. This isn't that bad.
No, the first one was bad. All right. Well, part of it is you're going to have to remember some things. Once you start remembering, this will get easier. What's R? R. Not the pirate R. Not R. You got 8? I wanted more than one person to get it. Did you get 8?
I did not. I'm a little bit confused about how to do this part.
Okay. R is equal to the square root of negative 4 radical 3 squared plus 4 squared. Make sure everybody's...
I got 2.
You've got to put negative 4 radical 3 in parentheses.
Oh, that can help.
Because it's only squaring the radical 3.
Oh, that makes sense.
Okay. So if this is my rectangular, R is 8, right? Now, what quadrant is this in? X is negative, Y is positive, right? So, if this is theta, isn't this negative 4 radical 3, and this is 4? Right? Surely somebody can tell me this angle.
Oh, it's 1 and negative radical 3.
So it's 2.
No, that's the length of that side.
Oh, pi over 30, pi over 6. So yeah, that. Oh, yeah.
Pi over 6.
Pi over 6.
This is pi over 6. This is what?
2 pi over 6. No, that's 5 pi. Yeah, that one. Uh-huh.
5 pi over 6 plus I sine of 5 pi over 6. Right? You good with that? Now, the very first problem I did was difficult. Do you want another one of those?
Yes.
Yes.
24 plus, now let's do negative 24 minus 7i. I need somebody to come up with R. You got what? 25, okay. R is 25. What quadrant is that angle in? 3? Is it going to be an angle we have dealt with? We've dealt with when the sides are the same, right? We have dealt with when one side's radical 3 times the other one. We have not dealt with weird numbers, right? I don't have a clue what it is. So, is theta, how can I find theta? Tangent of theta is what? 7 over 24? So what is theta equal to? Arctan of 7 over 24. So my complex number is 25 times the cosine of the arctangent of 7 over 24 plus I sine of the arctangent of 7 over 24. Correct? Is that right? Okay. So we're good? Now let's go the other way. Let's go from complex, from polar to rectangular. All right? We good? Liz is still frowning at it. Going the other way. I'm here to tell you it is a whole lot easier. Okay? Before I work this, you're going to see some of this in some abbreviation form. Rather than writing it all out, this right here is sometimes written in this form. All it means, this says cis 5 pi over 3, which means cosine 5 pi over 3 plus I sine 5 pi over 3. They just, instead of writing out cosine plus I sine, they put CIS. Well, I'm just telling you, I don't want you to see it and panic. It's the same thing. You can do it on your work if you don't want to write it all out. Okay? Now, how would I do this? Cosine 5 pi. 5 pi over 3 is in what quadrant? Fourth. Okay. So it's over here. What does this make this angle? Pi over 3 in radians, 60 in degrees. So isn't this 1 negative radical 3 and 2? Isn't it? Okay, so here we are, 18 times, what is the cosine of 5 pi over 3? 1/2 plus I, what is the sine of it? Negative radical 3 over 2, right? Can I distribute the 18? And I get 9 minus 9I radical 3. I could have said I 9 radical 3. I could have said 9 radical 3I. As long as I don't put the I under the radical. Right. So now this was in polar. This is in rectangular. Was that one easier? You want another one? I don't want pi there. I want a 90 degrees. Why not? What's wrong with 90 degrees? All right. Oh. Use your brain. Cosine 90 degrees. What's cosine of 90 degrees?
Isn't it the 0? Or, yeah. Oh, easy.
Isn't it 0?
It is.
Plus I. What's the sine of 90 degrees? Right? So what is the answer to this? No.
0 plus 43.
You do not have to put the 0.
Oh, perfect.
Okay?
That's the answer?
That's the answer. Okay? Page 722, 16 through 30 even. 16.